Everyone. In this session, we are going to discuss about LAB color space. This is a very important topic when we are in the research area of color image processing or any such particular topics where color image processing is concerned. We know the color space is the area or is the concept where we have the capability of defining different channels associated with colors. So L star, A star, B star is such color space with its own specialization or with its own capability of dealing with different colors. This LAB color space is defined by CAE and specified by the International Commission on Illumination. Now, sometimes we call it as LAB or sometimes L star, A star, B star. So don't matter. So first thing is that you just remember it as L, A star, B star or LAB simply. Right. Now, there you can clearly see that there are three channels LAB. Right. Now, this A, or you can say A star, and this B star, these two channels or layers are known as chromaticity layers, and actually these are the two color channels associated with this color space. And about this L is known as luminance or lightness. So L channel is known as luminance or lightness channel. Clear? Now let's discuss in detail about this. You can see here, this is the diagram of LAB color space. So A star value, if you look at this diagram, minus A to plus A. So minus A from green to plus A, that is red. So minus means green to red, there are different variation of color in this particular A star color space, color channel. Similarly, plus B, that is positive, to this minus B. Okay. So blue to means yellow to the blue. So there are different variation of colors in this B channel. Then L star value or L channel value you can see here 0 to 100, which clearly denotes the means luminance channel, or you can say intensity values associated. Well, I hope now this picture is clear to you. Let's come to the discussion in about this each layer in detail. Well, for that, let me clear this. Okay. Now, the A star layer indicates where the color falls along the red-green axis, and this B star, where the color falls along the blue-yellow axis. A star negative values indicate green, while positive values indicate magenta. B star negative values indicate blue, and positive values yellow. Okay. So don't confuse with the term magenta. Obviously, it's somewhat related to it. Now, a very important characteristics of this color space is that this is device independent color space. Means to say, this provides us the opportunity to communicate different colors across different devices. Some may ask you in interview or in such viva that why you have chosen this LAB color space for your research work or for your particular tasks, right? Then your answer should be that this is a device independent color space. So first benefit we have got that whatever the means color impression that we got through this color space in our system, that will be same if we means view the result in some another systems. Right. So this is device independent, not like RGB color space, which is device dependent. Clear? So you please note down this fact. Now, I hope it is clear to you. Then again, the one more benefit is that, let me tell you one more benefit about this channel is that there is a separate channel L for luminance where we can deal with the intensity values. So if we want to perform some specific operation on the intensity values without affecting the colors, then that opportunity we have with respect to this LAB color space. So two benefits we have directly seen. One is it is device independent, right? And another is that there is a special channel LSAR where we can deal with the intensity values without affecting the colors. So guys, I hope this is sufficient for this color space that you have to know. And okay, in the coming session, I'll show you practically how we can deal with this color space. But for the conceptual part, this is sufficient. If you have any doubt, then please ask me to comment. Thank you. Bye-bye.